Valeria. Su plática va a ser en inglés y nos va a hablar sobre la contribution of Neanderthal and Denisovan introgression to the genetic architecture of complex traits in present-day Mexico. Thank you.
Hi, everyone. Today I'm super happy to be here to present my work on Neanderthal and Denisovan introgression on complex trait variation, which is a follow-up on my undergrad thesis project, and it is advised. Can you hear me? Oh. Okay. Which is advised by Emilia Huerta Sanchez, Machel Sojail, and Diego Ortega del Vecchio. Okay, so I just want to briefly outline the presentation scheme. So first, I'm going to introduce you the relevance of complex trait variation, of archaic-introgressed on complex trait variation, and the major question of my project. Then I'm going to go over the methodology I'm employing and some initial results that I have, and finally, just future perspectives of my work. So starting with the introduction, the analysis of Neanderthal and Denisovan genomes have revealed a complex admixture landscape between modern humans and archae-humans. So here I have a oversimplified schema to show you how out of Africa modern humans interbred with archaic population, so that it's been estimated that contemporary populations have inherited about 2% of Neanderthal ancestry, or populations in Oceania have inherited about 5% of Denisovan ancestry. And as you can observe here, as a genomic footprint of archaic-introgressed, we can observe these Denisovan or Neanderthal introgressed haplotypes. And since they are distributed across the genome, they raise the possibility that they may be encompassing protein coding genes or functional genomic elements that impact the phenotypic variation of humans. So, for instance, I have a figure here from a paper that's from MacArthur et al. And in that paper, they were investigating the impact of Neanderthal introgressed variants in the UK biobank phenotypes. And so basically they found that Neanderthal ancestry is mostly depleted for those phenotypes except for skin and hair, which is particularly interesting. However, because of the well-known disparities of ancestry representation in genomic research, there's no, to our knowledge, there's no research that has investigated the impact of archaic-introgression on complex trait variation in admixed populations from the Americas and specifically in Mexico. And this has major implications for us to understand the human evolutionary history and the, like the impact of this archaic-introgression on the phenotypics of ancestry diverse populations. So the major question of my project is to know what is the actual contribution of archaic-introgressed variants to complex trait variation in Mexico. And the main goal that I have right now is to be able to estimate the proportion of phenotypic variants that can be attributed to Neanderthal and Denisovan introgressed variants in Mexican individuals. And the approach that I'm following right now is to compute partition heritability along the genome using a previously proposed method called RHEMC, and evolutionary annotations regarding ancestry, Neanderthal ancestry and Denisovan ancestry. So the methodology in general is that I'm using the Mexican Biobank Project, which gathers genome-wide genotype information of about 50,000 individuals that, as you can see, are broadly distributed across Mexico. And also phenotypic information for the same set of individuals of 22 traits that fall into 4 broader categories, such as anthropometric, familial disease history, human biochemical, and health-related traits. And I'm also using these genomic regions with Neanderthal ancestry that we identified using the same cohort and this program called S-Prime. That's basically a method that compares high linkages equilibrium regions in an admixed population to an unadmixed group to identify these introgressed regions. So doing that, we were able to identify these Neanderthal introgressed variants that we named NIPS. They are about 60,000, and they are putatively of Neanderthal origin, and they are also matching the anti-Neanderthal allele. And so using this information as input, as I mentioned, my main goal is to actually estimate the phenotypic variants that can be attributed to these NIPS. So I'm using the RHE method to compute partition heritability. That's basically to compute the variance component models to be able to estimate the heritability that is attributable to NIPS. And the annotations that I'm using is ancestry, such as Neanderthal and modern human, minor allele frequency and leakage disequilibrium, as they have been suggested to affect the genetic architecture of complex traits. And so, as part of my results, I first want to highlight the differences in these metrics between NIMS and modern human SNPs. So here in green, I'm showing you Neanderthal introgressed variants, and in pink, modern human SNPs. And in the first panel, I have minor allele frequency, and in the other, I have in sample LD score. So overall, we can observe that the SNPs tend to have lower minor allele frequency and higher LD scores compared to modern human SNPs, which is concordant with previous research that has compared, again, Neanderthal introgressed SNPs to modern human SNPs, but identified in European cohorts. However, one thing that is actually interesting here is that we can appreciate that the LD scores of Mexican individuals are higher to European individuals, and this would be potentially explained by admixture. And here, I was able to compute the NIPS heritability. So in this figure, I'm showing you in the x-axis the 22 traits that were measured in the Mexican Biobank, and they are color based on the domain they belong to. So in the first figure, I have NIPS heritability, and in the other, I have the Z-score testing if NIP heritability is equal to 0. So overall, I find that no MXB phenotype exhibits significant NIPS heritability. However, when I did the meta-analysis, that means that I basically grouped the phenotypes and compute the meta-NIPS heritability for each domain, I found that the skeletal phenotypes are significant. So overall, this Neanderthal introgressed variant signal is modest, as we would expect, since these Neanderthal introgressed SNPs represent a small proportion of the SNPs that are in the genome of these individuals. So in summary, with these initial results, I was able to show that NIPS tend to have lower minor allele frequency and higher LD scores compared to modern human SNPs, and also that there's no phenotype that has significant NIPS heritability. However, when doing the meta-analysis per domain, we found that meta-heritability for NIPS is significant for skeletal phenotypes. So as future perspectives, what I wanted to now is to repeat the same analysis, but now using Denisovan introgressed variants that were also detected as part of my undergrad thesis project. And since I got these Neanderthal introgressed variants or Denisovan introgressed variants to be able to actually pinpoint genomic regions of the genome to associate them with phenotypes. With that, I just want to acknowledge all the people that's involved in this project, and specifically to my amazing mentors, Emilia, Machal, and Diego, and the Mexican Biobank Project. And that's it. Thank you, and happy to take any questions.
Gracias, Valeria. ¿Alguien tiene alguna pregunta, comentario adicional para Valeria? ¿No? Tenemos un...
Hola, felicidades por el trabajo. Y mira, mi pregunta es en relación a las características fenotípicas son controladas por muchísimos genes. Tú demostraste la complejidad tan enorme y estás hablando de la herencia que podemos tener de una especie muy ancestral, los denisovanos. La cuestión es de todos los caracteres que muestrearon, ¿alguno de ellos está asociado a la especiación? Puedes decir, este es el que más nos está diferenciando, o no hay una manera de decir, este es el que más está
diferenciando. ¿Te refieres, o sea, como que venga de Denisovan o Neanderthal?
Sí, o sea, el pedacito que estás viendo de los denisovanos y neandertales en los mexicanos actuales,
sí,
lo que se heredó, y con relación a las características fenotípicas, si alguna de ellas, porque son muchísimas, alguna de ellas es la que está pesando más para la herencia de estas especies.
Por el momento es un poco complicado y hay de hecho mucha controversia en el medio de cuál es la mejor forma de hacer este tipo de análisis, principalmente por la complejidad que tiene trabajar con este tipo de variantes y porque es una proporción muy pequeña del genoma. Entonces, por ahora el approach que nos parece mejor y que probablemente hagamos es que, de hecho, como mencioné, utilizar estas variantes para poder ver si hay asociación directamente como SNP fenotipo, pero de estos 22 fenotipos que mostraron en el MXB, por ejemplo, diabetes, hace no mucho un paper encontró una asociación que para diabetes específicamente tener este SNP neanderthal, no recuerdo en qué gen, estaba asociado a tener mayor riesgo a tener diabetes. Entonces es como el único fenotipo de los 22 que hay aquí que podríamos tener la suerte de también encontrar la misma señal. Sin embargo, cuando sea capaz de hacer el análisis SNP por SNP y asociado a estos fenotipos, tal vez encontremos una señal más fuerte.
Ok, fabuloso, muchas gracias.
Gracias.
Muchas gracias, Valeria. Tenemos que continuar con el programa. Gracias.